Hello everyone. We have been given a matrix A, that is 1 2 3 0 2 5 and 0 0 minus 1. We have to find the eigenvalues of A inverse, A cube, 6A, A plus 3I, and last and not the least, A transpose. So the solution we are going to find out for all the given options. The first one, the matrix given is A is equal to 1 2 3 0 2 5 and 0 0 minus 1. Since we see that the lower triangle of this matrix is 0 0 0, so this implies that this is an upper triangular matrix. This is an upper triangular matrix. So the eigenvalue property will be implied here, which has been discussed in the previous videos, which is quite very important because it helps us determine various such questions quite easily. So the eigenvalue property will be, if a given matrix is either diagonal upper or a lower triangular matrix, then the eigenvalue will be leading diagonal element of the matrix, will be leading diagonal element. This is quite important, element of the matrix. So therefore, in this question we have found that this is an upper triangular matrix. So using the above property, this property, so we get that as the given matrix is upper triangular matrix. So therefore, using this property which we are using, we get the eigenvalue as 1 2 and minus 1. This is the first question. Now the first part. Now the solution for the second part. In the second part, we have to find the eigenvalue of A inverse. The second part, eigenvalue of A inverse. So for this we are going to use another property which has also been discussed in previous videos, as if A is a square matrix. This is a square matrix of order 3. So if A is a square matrix with lambda 1, lambda 2, lambda 3 till lambda n, then the eigenvalue then the eigenvalue will be of A inverse will be the values of 1 by lambda 1, 1 by lambda 2, and so on, and 1 by lambda n. 1 by lambda n. So the solution will be as the eigenvalues of A is equal to 1, 2 and minus 1. Therefore the eigenvalue of A inverse will be 1 by 1, 1 by 2 and 1 by minus 1, that is 1, 1 by 2 and minus 1. This is the solution of the second part. The third part we have to find the eigenvalue of AQ. In this we will show that how the eigenvalue of A cube will be found. If A matrix has the eigenvalues as lambda 1, lambda 2, lambda n, then for A cube matrix, then A cube matrix, the eigenvalues will be lambda 1 cube, lambda 2 cube and lambda n cube. So the eigenvalues of the matrix A cube will be 1 cube, 2 cube and minus 1 cube, that is 1, 8 and minus 1. This is the solution for the third part. Now the fourth part, we have been asked to find out the eigenvalue of 6a. This is quite simple, which I think you will be able to figure out quite easily, or you have figured out. We have to find the eigenvalues of A as 1, 2, 3, 0, 2, 5, 0, 0, minus 1. So 6a, as you all will be knowing, will give the matrix as 6, 12, 18, 0, 12, 30, 0, 0 and minus 6. So the eigenvalues will be quite simple, as we will be using the properties. So we will get the eigenvalues as 6, 12 and minus 6. This is quite simple, as you know that, as you saw that. Now the fifth one is quite important. We have to find the eigenvalue of A plus 3i. Here I represents identity matrix. I represents identity matrix. since I represents identity matrix, and here it is given that I has the order of 1, so the value of I will be 1. If the order of I is 2, then we will get in the matrix X 1 0 0 1, as you all will be knowing, and I3 will be 3 cross 3 matrix, that is 1 0 0 0 1 0 and 0 0 1. So we will get the answer as the eigen values will be A. We also know the value of A, and the eigenvalue of A, that is 1 plus 3 into 1 comma 2 plus 3 into 1 comma and minus 1 plus 3 into 1, that is 4 5 and 2. So the eigenvalues are 4 5 and 2. Now the sixth question. Sixth question is, we have to find the eigenvalues of A transpose. Sixth one is the eigenvalue of A transpose. Here we know that the eigenvalue of the matrix and its transpose is the same. So we will get the same result as the eigenvalues as of A transpose as 1 2 and minus 1.